Introduction of separation and identification of lipstick pigment using TLC. What is chromatography? Chromatography is an analytical technique used to separate a given mixture into its components. Chromatography helps to separate mixture into individual components and identify substances in a sample. Chromatography is a commonly used technique in clinical laboratories for diagnosing inborn carbohydrate, protein and lipid metabolism errors. Basis of thin layer chromatography or TLC is a method for chromatographic analysis on a thin layer absorbent held on a glass plate. TLC based on differential adsorption and partitioning of compound between stationary phase, which is silica gel, and mobile phase is the solvent. RF values are used for identification of separation into visible spot. The RF formula is distance traveled by component divided with distance traveled by solvent form. The purpose of study for lipstick pigment using TLC is to separate different dye components that present in the lipstick, to identify and compare pigment composition between different lipstick brands or shades, and to assess product composition and authenticity.
For the theory of this experiment, we use thin layer chromatography or TLC, which is an analytical technique used to spread and identify the component of a mixture based on their different interaction with a stationary phase and mobile phase. In this experiment, the stationary phase is a thin layer of silica gel coated on the TLC plate, while the mobile phase is a solvent that moves outward through the plate by capillary action. When the lipstick sample is applied to the TLC plate and placed in the solvent, the different pigments move at different rate because they have different polarities and solubilities. Pigments that are more soluble in the solvent travel further, whereas the pigments that interact more strongly with the silica gel move more slowly. As the result, the pigment spread into distinct color spots on the TLC plate. These separations allow us to identify and compare the pigment present in different lipstick samples. In conclusion, TLC is a simple, rapid, and effective method for separating and identify lipstick pigment based on their different affinities towards the stationary and mobile phase. Next, I will explain the rotation factor or RF value. The RF value is a numerical value used in thin layer chromatography to describe how far a pigment travels on the TLC plate and to help identify spread compound. The RF value is calculated by dividing the distance travelled by the pigment spot by the distance travelled by the solvent front from the origin line. RF value range from 0 to 1. A higher RF value indicates that the pigment has a greater affinity for the mobile phase and travel further with the solvent. In contrast, a lower RF value indicates a stronger attraction to a stationary phase, causing the pigment to move more slowly. By comparing the RF value and the color of the spot obtained, we can determine whether different lipstick sample contain similar or different pigment. In conclusion, the RF value is an important parameter in TLC because it helps identify and compare the pigment present in different lipstick samples.
Now we move on to the methodology. First, the sample preparation. Few brands of commercial lipstick with red shade were selected. Then a small amount of each of the red lipstick were then mixed with a solvent such as acetone. Then by using a capillary tube, apply a tiny spot onto the TLC plate and label each of the brand. The second one is TLC analysis and comparison. The silica gel aluminum TLC plate is activated at 100 Celsius for 1 hour. Then apply tiny spot of the pigment extract onto the baseline of the silica gel TLC plate. Mobile phase use for this is ethyl acetate with hexane with 7:3 ratio. Then the TLC plate is then developed until the solvent reach 3/4 of the plate. Then the plate is air dried after the development. The spot is observed under white light and UV light. Then the RF value were calculated for each pigments of the brands.
Good day everyone, today I am presenting a review on the separations and identifications of lipstick pigment using TLC, focusing on the experimental data compiled by researcher Joshi in 2013. Let's begin with the sample collection phase. To conduct a true and comparative analysis, a total of 12 lipstick samples were gathered, split evenly between two distinct market segments as displayed in the table. On the left, there's the branded Revlon lipstick shade used in the study. The selection included 6 distinct color ranging from pink and brown to deep maroon, such as Frost Rose Pearl 334 and Bridal Dream 104. On the right, there's the local brand lipstick selected to match those exact same color profile, featuring local variant like Virus 14 and Ivy Made Soft 70. If you look at the picture, you can see the actual prepared TLC plate from the experiment. Each sample was dissolved in a solvent and carefully spotted onto the baseline. The experimental reason was set up to determine whether premium brand and budget-friendly local alternative rely on the same underlying chemical pigment or if their formulation differ completely. Next, let's take a look at the chromatography result after the plate were dissolved in the solvent system consisting of toluene, benzene and diethyl ether in the 12:6:2 ratio. As summarized in the data table on the picture, the data show a stark contrast between the two categories. The branded Revlon lipstick proved to have highly stable streamlined formulations separating into fewer components, typically between 1 to 4 distinct spots. Conversely, the local brand lipstick revealed highly complex chemical mixture yielding anywhere from 6 to 8 individual pigment spots on the sample. We can see the visual on the picture. Figure 6 shows the cleaner, more isolated spot obtained from the Revlon lipstick when viewed under ultraviolet light. Right below it, figure 7 display the local brand, which left behind a crowded multicolored trail of components. This clearly indicate that the local alternative used a much more complex blend of primary dye to achieve their final shade. Finally, to convert this visual observation into analytical data, the migration distance was measured to calculate the retention value, which is the distance traveled by lipstick component from the spotted pencil line divided with distance the solvent moved from the spotted pencil line. In this experiment, the solvent front traveled a constant distance of exactly 10 cm. So let's take a look at the breakdown on the slide. For spot 1, margin is 0.7 cm, resulting in RF value of 0.07. For spot 3, margin is 2.7 cm, giving an RF value of 0.27. All the way up to spot 6, which travels 7.6 cm to give an RF value of 0.76. By cross-referencing this precise mathematical RF value across all 12 samples, the study successfully identified which specific dye compound are shared across industry and which one are unique to premium versus local formation.
Lastly, I will conclude about this experiment. The obtained RF values ranging from 0 to 1 indicate different affinities of pigment towards the solvent system.
and silica gel, where pigments with higher RF values had stronger interaction with the mobile phase. Overall, the separation of lipstick pigment using TLC successfully demonstrated the application of chromatography in cosmetic analysis. This technique can help in quality control, authenticity testing, and understanding the chemical composition of cosmetic products.